Hello guys, today we will see the physical significance of pressure. What is pressure is and what is its physical significance. In short video we will see. Okay, let's start. First of all, we see the definition of the pressure, then the mathematical formula, then we will see the physical significance. Right? Let's go. Its definition is pressure is defined as external normal force per unit area. This area may be real or imaginary. Okay, imaginary. So the pressure is external normal force per unit area. This two word is very important, external and normal force. If whenever we will define the pressure, we see these two words remain in our mind, external and normal force. Okay, then mathematical formula, why external, why normal force, we will see. Okay, the pressure, every point with logical pressure P equal to external force per area. This force is external normal force. Okay, this force is external normal force, is real or imaginary area. Okay, let's see an example. Let a container is filled with water, any liquid, maybe it's water, and the water is exert force on the container wall. It's normal. This wall is exerted normal, and also this wall, water is force is normal. This pressure is called P equal to force by area. This force is normal force, externally force. This force and the force is external, not internal. This in the case of wall, this force is external to the surface. This is the surface, this is surface, this is surface, this is surface, this is surface, and for this surface, this water force in the wall is external force. So that's why we see that we say that external force per area, per unit area. This area may be real, we say that this area may be real and real. This area is real, this area is real, this area is real. Then see the what is imaginary area. Let's see the in the surface of the liquid, in the depth of x distance, we consider an surface area. That area is imaginary area. And what is the pressure in this surface area? In this imaginary area, the pressure is exerted on the upper liquid force. This is, and also lower liquid force exerted on this surface, imaginary surface area, is normally all time it's normally, not it's oblique, and that type of outside normally. Whenever pressure is come in picture, then it's a external normal force per unit area. We will see. Okay, then another point is important, that it is also important, and when pressure is come, then it's a external, it's a compressive force, it's a compressive nature. Why compressive nature? It's a physical significance. See that if we consider that surface, and if we see the free body diagram, this pressure force is P, then this is the ground, suppose, and also its ground is also exerted on nature. Then, and this force and these two forces are compressive in nature. This for compressive nature. That's why pressure Pressure is compressive in nature. Compressive in nature. If we see and the significance, what is significance? Significance and pressure equal to force by area. This force is by the Newton law. Force equal to the force equal to mass into acceleration, and this acceleration equal to final velocity minus initial velocity by t. If we multiply mv minus mu by t, change of momentum, that this is change of momentum per time. Change of momentum, whenever in picture come to momentum, then it's tell about the collision. So if we see in the case of water molecule, in water molecule there are the molecule of the water is collision each other, and pressure is exerted on the surface of the container. So pressure is represent. Okay, so we say that pressure is represent collisions. Pressure is represent collision, number of collision per second. So actually pressure is represent number of collision per second. If in container, in completely vacuum container, if there is no air in this container, there is no air, there is no molecule in this container, so if there is no molecule, then collision is zero. So pressure in this container, vacuum container, pressure equal to 0. So that's why we say that pressure is represents number of collision per second. So we see that physical significance of pressure and with proper example. Okay, so thank you for this video, and for follow more video, you can follow my channel Technical KM.